Core Concepts for Open Architecture AV Design. Chapter 14. Third-Party and External Control I/O. The goals for this chapter are: use the Configure Remote Control Ports window to manage UDP, TCP, RS-232 and RS-485. Review the common protocol used to communicate with Composer Series DSPs via a third-party control interface. Configure external control input, also known as general purpose input-output. Utilize local logic outputs to drive LEDs or to control external relays. Understand the capabilities of Lua Scripting for communicating with third-party hardware via TCP, UDP, or HTTP. Explore intelligent modules interactions with other modules through input and output control pins. This chapter covers Composer software settings and Symetrix hardware connections of third-party devices and external control. Refer to Chapter 6 for instruction on programming control numbers in Composer. Prism is equipped with a single Ethernet port. Radius and Edge units are equipped with dual Ethernet ports and one RS-232 port. Either port may be used to control the units. Ethernet is generally preferred because of the simplified setup and higher data rates. Generally, no special configuration is required for the Ethernet port. The Ethernet port on the unit may be used for both Composer control and remote control. Connect the RS-232-based remote control to the RS-232 port for third-party control. Typically, this connection uses a straight-through cable. To configure either the Ethernet port or RS-232 port, right-click the DSP and choose Unit Properties, then click Configure Remote Control Ports. The Configure Remote Control Ports window has tabs for UDP, TCP, RS-232 and RS-485. The RS-485 network is used for Symetrix ARC remotes. The UDP, TCP and RS-232 tabs are used to configure the remote control port modes. When quiet mode is turned on, it restricts the output to just ACK, acknowledged, NAK, not acknowledged, or simple values. Quiet mode is the default setting. When echo mode is turned on, all characters that are received over the control port are sent or echoed back. This mode is useful when using a terminal program for testing or debugging. The deaf mode option is provided to ignore input commands being received over the port. It is good practice to turn on deaf mode when using the control port to control third-party devices to avoid issues with their protocol triggering unexpected commands in Composer. UDP and TCP control communication uses port 48631. UDP only communicates with one control at a time and responds to the last control to communicate. TCP communicates with up to 6 controllers at the same time. If a 7th controller communicates with the DSP, Composer disconnects from the controlling device least recently used so that it can communicate with the 7th controller. RS-232 can communicate over a wide range of baud rates. 57600 is the default. The protocol used to communicate with Composer-based Symetrix DSPs via a third-party control interface is all the same. Legacy Symetrix products use the same control protocol. The protocol consists of human-readable text commands and responses. A comprehensive list and explanation of the protocol can be found in the Composer help files. Navigate to the control protocol article or search for it directly. This section of the chapter focuses on the 3 most commonly used control types: Control Set, CS, Change Control, CC, and Load Preset, LP. Use the Control Set, or CS command, to move a control position to a new absolute value. The command must specify the control number and the new control position. This command is typically used for control of a button. Assign a control number to the mute button and enable push. Refer to Chapter 6 for instruction on programming control numbers in Composer. The control number controls the state of the button. The push data provides feedback to the third-party control system with the value of that control number. To activate the mute for this gain module, the command is CS for control set, 2 referring to the control number, and 65535 to change the value to max or on, then the carriage return. Monitor the feedback with the Symetrix remote terminal, or Control F10. The push data now reports control number 2 with a value of 65535. To deactivate the mute for this gain module, the command is CS, 2, 0, then the carriage return. Use the Symetrix remote terminal to monitor the feedback. The push data now reports control number 2 with a value of 0, deactivating the mute. Use the change control, or CC command, to move a control to a new relative value. This command increments or decrements a control by a specified amount. The command must specify the control number, whether it is to be increased or decreased, and the amount to change by. The most common use for this command is fader or knob control. In this example, the CC command is used to control a gain fader. Assign a control number to the gain fader and enable push. Refer to Chapter 6 for instruction on programming control numbers in Composer. Next, use the control number to make the fader adjustments in 1 dB increments. There are 84 dB steps between -72 and +12. The full range scale of a fader is 0 to 65535, so 65535 divided by 84 is approximately 780. The command is CC for change control 1, the control number 1, increment 780 by this amount, then the carriage return. Use a value of 1 in the decrement or increment position to move the fader up, a value of 0 moves the fader down. Use a value of 780 in the amount field to move the fader in a 1 dB increment. Use the Symetrix remote terminal to monitor the feedback. The push data reports control number 1 moved up by a 780 increment, or 1 dB. Now, move the fader down by 1 dB. The command is CC 1, 0, 780, then the carriage return. Use 0 in the decrement or increment field to move the fader down. Use 780 in the amount field to move the fader in a 1 dB increment. Use the Symetrix remote terminal to monitor the feedback. The push data reports control number 1 moved down by a 780 increment, or 1 dB. The load preset or LP command loads the specified preset from 1 to 1000. To recall preset number 1, the command is LP1, then carriage return. If the command is accepted, a message with ACK, acknowledged, is delivered. If the command was interpreted, but fails for any reason, the message will be NAK, not acknowledged. Each external control input, also known as a general purpose input-output or GPIO, can be configured in one of two modes, as a dual switch closure or a potentiometer. Dual switch closure mode is most commonly used with push-to-talk or push-to-mute buttons on microphones, for an emergency system or fire alarm relay connection that mutes or overrides the audio system, and for room combining that use switches on movable wall partitions. The potentiometer mode is typically used to create an inexpensive volume control for an input, source, zone, or output. In operational mode, switch closure versus potentiometer must first be configured using the Configure External Control Inputs dialog of the DSP unit properties. While online with the DSP using Composer software, a potentiometer can be calibrated for maximum travel or scaled to a desired range. Following is an example of using a contact closure to trigger an emergency system mute. First, add the emergency system mute supermodule to the site file. Next, double-click the supermodule to open its control screen. Right-click the button of the supermodule and select Setup to Remote Control. From the Setup Remote Control window, select Local Analog Input from the DSP the switch is connected to. Then use the drop-down menu to select the external control input. This example uses switch 1A. Click OK, switch 1A is now assigned to the button of the supermodule. When the switch is open, the button is off and preset 1000 unmutes the outputs. When the switch is closed, the button is on and preset 999 is recalled to mute all the outputs. In this example, external control input number 2 is used for volume control with an analog potentiometer. First, configure input number 2 for pot using the DSP unit properties. Next, open the module with the fader being controlled. Right-click the fader and choose Setup to Remote Control. Use the drop-down menu and select Pot 2, then click OK. Control of that fader has now been assigned to external control input number 2. Typically, local logic outputs are utilized in a couple of different ways, driving LEDs in order to give visual feedback to an end user, or controlling an external relay for switching other equipment such as a projector screen, or rack of other equipment. This is a very important concept. When the transistor is inactive, 5 volts is present at the logic output. When the transistor is activated, the 5 volts is shunted to ground through the transistor's emitter, which results in 0 volts at the logic output. Each logic output is the open collector of a switching transistor that has its emitter tied to ground. This means that they are not dry contacts that are simply open or closed. Stating again, the logic output is pulled high, 5 volts, when inactive. The logic output goes low, 0 volts, when active. The maximum logic output source current is 10 milliamps. The maximum external power supply voltage is 24 volts DC. The maximum external power supply current sinking is 50 milliamps. In this example, a third-party control system is used to trigger an external relay that lowers and raises a projector screen using local logic outputs. First, add a one-button latched module from the toolkit under Control Modules, Control Inputs. Next, add the local logic output module under the Control Outputs menu. Then, wire the one-button latched module to the local logic output module. Each local logic output module is specific to the output port of the DSP. Assign a control number to the on button of the one-button latched module. Refer to Chapter 6 for instruction on programming control numbers in Composer. With Symetrix Remote Terminal, simulate the third-party control system, send a CS command to activate the on button of the latched module. This activates the local logic output number 1 and triggers the relay to lower the projector screen. Now, send a CS command to deactivate the on button of the latched module. This deactivates the local logic output number 1 and triggers the relay to raise the projector screen. In this example, external control inputs and local logic outputs are combined with LED feedback for a push-to-talk mic. From the toolkit, a one-button momentary module is added. Next, a one-button processor supermodule is added. Then, the one-button momentary module is wired to the one-button processor supermodule. From the toolkit, 2 local logic output modules are added. One is for the microphone's green LED and one is for the red LED. Next, the outputs of the one-button processor supermodule are wired to the local logic outputs. The on button of the one-button momentary is assigned to external control input switch 1A. Now, the module being used to control the mic audio is opened. Right-click the mute button and select Setup to Remote Control. From the Setup Remote Control window, Control Signal Assignment is selected. Then click the Select button and choose One Off from the One-Button Processor menu. The red LED of the button processor is now assigned to the mute of the gain module. Anytime the LED is red, the mic is muted. When the LED is green, the mic is unmuted. The X control increases the GPIO count of our Edge and Radius NX DSPs, with 2 RS-232 ports, 8 analog inputs and 16 logic outputs, without purchasing additional DSPs. Moreover, the X control adds RS-232 capabilities to DSPs that do not have onboard RS-232, such as our Prism series. Intelligent modules expand the capabilities of a Composer site with customizable control of third-party devices and powerful manipulation of control data within a design. For example, this AT&D 1061 array microphone. Like any other module within Composer, intelligent modules are easy to use and can be created by the system designer or imported from our library of pre-made solutions. Comprised of a custom control view and a script written in Lua, users interact with the controls to trigger functionality in the script. The script can communicate with a third-party piece of hardware via TCP, UDP, or HTTP, allowing a user to monitor and control that hardware. Intelligent modules can also interact with other modules in a design through input and output control pins. Intelligent modules are most often used to control third-party hardware, allowing any product to feel like a native device within the Symetrix ecosystem. They can also be used to solve complicated logic problems, delivering almost any functionality you can imagine. Any product that has an available application programming interface, or API, from the manufacturer and is managed over Ethernet may be controlled by custom scripting. Since this was a quick introduction to intelligent modules, there are more courses in your course list that get into more detail. The Configure Remote Control Ports window has tabs for UDP, TCP, RS-232 and RS-485. The RS-485 network is used for Symetrix ARC remotes. The UDP, TCP and RS-232 tabs are used to configure the remote control port modes. There is a common protocol used to communicate with Composer Series DSPs via a third-party control interface. Legacy products use the same control protocol. The protocol consists of human-readable text commands and responses. Each external control input, also known as a general-purpose input-output (GPIO), can be configured as a dual-switch closure or a potentiometer. Typically, local logic outputs are utilized to drive LEDs in order to give visual feedback to end users, or to control external relays for switching other equipment. Lua Scripting can communicate with a third-party piece of hardware via TCP, UDP, or HTTP, allowing a user to monitor and control that hardware.